is to introduce Katie Antypas from NSF. She is the director of the Office of Cyberinfrastructure. Previously, she was a deputy director at NERSC at the Lawrence Berkeley National Lab, where she led a number of projects, including she was a project director for the large-scale high-performance computing system acquisitions. She was also the director of hardware and integration of exascale computing projects and many others. And we are extremely happy to have Katie here with us to talk about leveraging the NSF cyber infrastructure to support major facilities. Welcome, Katie.
Okay, thank you so much. All right, good morning, everyone. It's great to be here on the warm side of the country. I personally could have driven here faster from San Francisco, but I made it in around midnight last night. I'm incredibly happy to be here. This is a topic that is really near and dear to my heart. As Eva mentioned, I was at NERSC, the National Energy Research Scientific Computing Center, which is one of the high-performance computing centers run by the Department of Energy Office of Science. And so for about a decade, I served as the data department head, and our whole goal was to connect the high-performance computing facilities to Department of Energy's experimental and observational facilities. They're slightly different language, but telescopes, light sources, genomic sequencing facilities, and then smaller instruments of discovery too, like electron microscopy. And I mean, what I came to realize, sometimes painfully over that decade-long period, was that the problem, for the most part, it was not the compute, right? It was not connecting. The compute was not the problem. It was everything else. And it was the language that we used that was different. It was bottlenecks in the networks. It was the way people wanted to access systems very interactively. It was the number of jobs that they just tried to send in through the system that would flood the system. So I deeply appreciate this meeting and a place where the community can come together, the CI research community as well as the facilities communities. I also appreciate that meetings like this can be a clearinghouse for different facilities from completely different domains to get together and share best practices. One of my experiences was that the lessons learned with the Joint Genome Institute, a genomic sequencing facility, they had many of the same challenges as our light source community. But there was no other meetings where these two communities really talk to each other. So I'm excited to talk to you today about how OAC invests and supports this cyber infrastructure for major facilities. And then also at the end of the talk, at this point, I cannot give a talk without mentioning the NARE, which is the National AI Research Resource. The NARE is launching next week, and so I'm going to give you all an update without revealing everything about the launch that will be happening next week. So here we go. So I think you all are familiar with OAC. Our vision, our goals is really to transform science and engineering research through an integrated cyber infrastructure ecosystem. And OAC is really a unique office in the entire NSF in that we support and research on the fundamental CI, but also run production systems and services. And it's an incredibly, I think, amazing office where you get to see that research transitioning into practice. And I think that's one of the unique aspects of what we do in OAC, and all of your feedback and work really helps us to think about the transitioning in that and for those communities. So in OAC, we have 5 key investment themes or areas. Advanced computing is one, supporting those production systems. Networking and cybersecurity is another key bucket, learning and workforce development, software and data CI, and then kind of a broad bucket of kind of strategic investments that happen year to year. I've learned that these are not clear boundaries. They often overlap. But what we'll see is that in supporting major facilities, the infrastructure and the research really cross-cuts through all of these different investment areas. And so OAC has long partnered with NSF to support the development of CI pathways for major facilities. And again, they really span this whole level of all of OAC's investment areas. I would say right now, where do we have a current spotlight? There's a lot of focus right now on what's happening at the edge with sensors and that are in the field. I think another key challenge we're seeing for facilities is around data discovery. Some of the data can be so large that it is hard to find or reuse or index, and that's a theme that we hear over and over again. And then, of course, how can AI aid in the discovery process? And so OAC's portfolio supports the cyber infrastructure around all of these areas, starting with communities of practice, such as this one here, networking security, advanced computing, software data infrastructure, and really training and user support. And so I want to walk through these here today and just discuss all of our investments in these areas. I wanted to start with, oops, sorry, that was animated. I wanted to start with communities of practice, really with the people, because I think without communities like this, then the impact of the science is much less. And I know you are all familiar with trying to have a conversation with someone in a completely different field, use different language. And I mean, I find it even between DOE and NSF, and that's in the computing world. So then when you're going between a domain scientist and a computing or cyber infrastructure language, that can be a real challenge. It takes building trust between communities in order to make this science work. And so I appreciate all the work that the CI Compass team is doing. We have many other communities of practice or centers of excellence, whether it's trusted CI, providing cybersecurity center of excellence and a community of practice there, research security operations as well. More recently, we have a community of practice around minority serving institutions that is helping us reach broader communities. And then, of course, RCD Nexus through training and workforce development, and the Science Gateways communities as well. Networking and security, of course, is a key research, a key requirement for our major facilities. And in OAC, we invest in networking from the campus level all the way to the international scale level. We have networking and security test beds such as Sphere and Fabric. And these are critical for really investigating the future capabilities where networking can help us in the discovery process, caching in the network, bringing the data closer to compute, distributing that data is going to be critical for discovery as we move forward. I think our advanced computing portfolio is pretty well known. We have systems that are distributed across the center, across the country. These range from, I call them innovative production systems, to a set of new test beds and prototypes. And these prototypes, they by their year 3, they need to have users on them and moving into a production operation. We have our leadership class system, Frontera, right now at TAC, and then a number of as well, such as PATH and the Open Science Grid, and then Access serves as that central point as well. We also provide access to a number of cloud technologies. These are currently run out of a sister division at NSF, but we have very close collaborations with them. I like to put it more explicitly that, and make sure that the community knows that we have some of the fastest and most advanced computing systems available for your research without charge, free of charge to you. It's not free for us, but it is free for you. And we want to make sure that the community, especially as we move into an era where AI demands are increasing, that the community is, very aware of all of these resources that we have available to you and how to get access to them. And the way that we do that is through our access program. And I really like to boil access down to simple language. What we have available is advanced computing, data systems, services, and support. Who is eligible? You all are eligible. Academic and government researchers and students are eligible, and we have a really link right there to get started. I think it's crucial that we reach out to new communities that are just finding that their department cluster is no longer adequate, and we are able to graduate communities from their local or regional institutions up to these national scale resources. Another big part of our portfolio in OAC is our Cyber Infrastructure for Sustained Scientific Innovation, CSSI. This is our data and software infrastructure portfolio. This is really a huge portfolio. I think we made close to 40 or 50 awards last year. That happens regularly over the years. And the categories are very broad, from core research infrastructure to CI that is really targeting major facilities. And so I had our program officer, Varun, just pull some of the recent awards that are from the supporting experimental and observational science. This is an eye chart. I'm just going to leave it with you. But I was actually very curious. I said, well, how many do we have? And this is just 1 year. There's 15 or so awards. And so this is clearly a really active community that is requiring and needing CI. If we move on to our learning and workforce development portfolio, I will tell you, this is the language that is still the most confusing to me as someone coming in, is that, who are we targeting? And we really look for learning and workforce development across a couple different categories. I call them like end users, people who are the scientists, domain scientists, researchers using our OAC-supported infrastructure. Then we have CI contributors. I think of those as the teams of researchers that are developing the software and the infrastructure that will run on or be part of CI. And then the professionals, the people whose careers are made of supporting and running this infrastructure. And so now I want to move on to a couple recent highlights and examples from the community. Some of these are kind of hot off the press, and I thank some of the folks in the room for providing me some content here. And so the first example I wanted to provide was from the National Radio Astronomy Observatory and NRAO. And so this was an example of a data analysis run that happened just December 18th. So about a month, exactly a month ago. And it was a data set that had not been analyzed for over about a decade, about 170 terabytes in size. And this particular data set was looking at a small portion of the sky for a very long time, so-called deep imaging. And this particular science is important for understanding the parameters of the universe evolution, and also understanding some of those weaker signals coming from outside the galaxy that can be an indicator of time as well. And so the NRAO team partnered with path and the Center for High Throughput Computing to develop a distributed data analysis algorithm that used HT Condor. And then just about a month ago, they were able to analyze this data across 12 different sites. This peaked to using 100 GPUs concurrently. And this analysis happened about over 1,500 jobs. And the result ended with the deepest image from the very large array that has been imaged. And so I think this is a great example of communities coming together, right, of a data set that had been sitting there collecting dust, hadn't been analyzed, and then our communities came together and were able to turn this data set into science results. The next example I wanted to provide isn't from a large facility, but I wanted to show a recent award through our RAPID program that was in response to the devastating Maui fires from last fall. And so this award was building on a couple of OAC investments, including SAGE, SAGE-3, and the Mesonet. And the goal here is to provide a proof of concept for supporting and investigating future hazard monitoring and in the recovery process as well. And so we were able to turn this around very quickly. I think Kevin Thompson turned this award around in a record 1 day or so to get this out to the community. The next example I wanted to bring up was OAC's really long-term investments. So this particular example kind of describes how we go from a conceptualization phase. This was a workshop held jointly with the physics division on multi-messenger astrophysics. This was back in 2018. Later that year, this turned into an award for collaborative research, a community planning award, and now we're starting to see some of the results from those long-term and community investments, different frameworks for data discovery in messenger astrophysics that are being applied at LIGO and other sites. Okay, so I want to move on to some new initiatives here in OAC. I would say a key theme that is coming up repeatedly for us is integration across CI resources, integration of different science domains, and integration and organization of our own portfolio. So a key theme that you'll hear from me repeatedly is the real need to continue to advance and interconnect our broad ecosystem within OAC. I think we have an incredible set of CI resources available to the community. I do think it can be hard to find them, and it can be hard to understand all the resources that are available. And so I think we want to move in a direction where we're thinking of ourselves, particularly some of our advanced computing capabilities, really as a portfolio of capabilities, even though, of course, these are individual awards. And so we'll be working a lot on that with our program officers. This isn't just, I say we have some requirements here as well. So the CHIPS and Science Act that was recently passed really requires us in OAC to kind of think more strategically and gather information and requirements from the community, and to make sure that we are publishing kind of these reports every couple of years. And so I would say we want to do this regardless of whether this was in the CHIPS and Science Act as well. I think we absolutely need to do this to make it easier to bring new communities to our, to be able to use our CI. Another key initiative moving forward is the National Discovery Cloud for Climate. And so in FY23, NSF included in our budget request a National Discovery Cloud for Climate that would federate advanced computing, data, software, and networking resources and connect with the geo and climate community as well. I will note this portfolio was being put together by Amy Walton, the deputy director in OAC, really right as I was starting. And I was watching her put this portfolio together and thinking, what are they doing? They are putting together advanced compute. They're putting together engagement teams. They brought in all these geo and bio projects as well. But it's been really interesting and great to see these communities begin to talk to each other and build capabilities across across their different areas. And so I'm really excited to see what comes from this NDCC portfolio in the next year here. Some of the key research challenges that this I'd say portfolio are facing is how to democratize access to data sets and enable AI-ready data sets, creating the pipelines and tools for CI discovery. Okay, so now I want to move on to an update on NAIR for you all. So is NAIR a household name? Do you all know what NAIR is at this point, or no? This is great. Okay, so I see some shaking heads, so I'm going to take a step back here. So the National AI Research Resource, the vision for the NAIR is a broadly accessible, a widely accessible national research infrastructure that will power AI R&D for this country. And we'll do that through access to high-performance computing, cloud computing, data sets, training, models, software, and user support as well. And the key goals for this concept of the NAIR are to spur innovation for the country, to increase the diversity of talent in AI, improve the overall capacity for AI R&D in the country, and then to advance trustworthy AI. And so in that last key goal there, advancing trustworthy AI, that was a key theme, the key theme in the AI executive order that was released on October 30th of last year. For this particular community, I don't know that this slide is needed, but I have been asked at times, well, why do we need an NAIR? We have large-scale computing in this country. Is that sufficient? And I think the answer is clearly no. That right now the resources that are needed to even participate in the AI ecosystem, they're increasingly being concentrated in the largest technology companies, the most well-resourced universities and institutes, and we need to assure that the research community, those researchers that are investigating AI for the public good, to serve the public interest, and that are exploring those key societal challenges, that those researchers have access to the resources necessary to advance their science and AI as well. And so how did we get here? It's been a road started in about 2020 with the AI Initiative Act. The AI Initiative Act congressionally mandated the formation of a task force called the NAIR Task Force to look at the feasibility of this concept of the NAIR, and if it was deemed feasible, to provide a roadmap. And so this task force, they worked together for about 18 months and produced a report that laid out a roadmap for the NAIR. This report was published almost exactly a year ago in January of 2023. Now, I will say there's many reports that get published, right? You've all been part of publishing reports. This one has weight and is getting a lot of attention. The NAIR, the concept for the NAIR, it appears to have really wide support from both rural areas that want to assure that AI talent comes to their areas, as well as making sure that the NAIR a key theme for the NAIR is reaching out to new and broad communities. And so in March of this year, actually before my time at OAC, an interagency working group was formed with about 14 different agencies. This interagency working group was led by OSTP and NSF, and then the executive order on trustworthy AI was released October 30th, and that directed NSF and our collaborating agencies to launch the NAIR pilot within 90 days. So we're in that we're coming to the close of that 90-day window right now. And so we are launching the pilot next week. It's been quite a road here. What we've been doing in the interim here is really reaching out to a lot of non-governmental partners to get them on board and get their their contributions to the pilot. It's worth remembering that we were directed to launch this pilot with our existing resources and under existing budgetary authorities. And so agencies are coming together to contribute their resources, industries coming with in-kind contributions for the NAIR. This launch in next week is really an initial launch. I think the interesting work, the fun work actually starts after the launch as we begin integrating more resources and connecting researchers with those resources. And so our intention is there'll be an initial call for allocations on just a couple of high-performance computing systems, and then there'll be a wider open call in the springtime. So when I was describing the NAIR task force's overall report, it was envisioned to be a very large program. It was envisioned to be a $2.6 billion initiative over 6 years. That is clearly not where we are today. Okay, we are at the stage where we are launching a pilot. It's going to be limited scale, and it is a proof of concept that is intended to show the impact and the value of this NAIR concept. We want to support new and novel AI research and reach new communities as well. And then I think another really key aspect of the pilot is getting our feet wet and trying and learning so that we can design together a larger NAIR. We know this field is moving incredibly fast, and so this is not like we have a blueprint, we're gonna lay it down and just build to that specification. It's gonna take a lot of engagement with the community, a lot of co-design in order to make this work. So the launch next week, there are about 4 key elements to it. The NAIR pilot portal will go live. There will be a call for allocations on an initial set of high-performance computing systems. There will be, again, an initial set of data sets that have been provided by our collaborating agencies. And then there also will be an RFI, a survey for researcher and educator use cases. So I'll say right now that I might have a friendly bet with someone on how many responses that we can get to this survey. And so I said, well, I think we could maybe get 5 digits. And this person said, Katie, you're going to be lucky if you get 3. And so I am seeking all of your help to make sure we at least get 4. But more seriously, I would say we really need every graduate student that is scrounging for computing access, for data access, to fill out this survey, to describe their use cases, to send us their priority use cases, so that we can demonstrate this is a national imperative. This is urgent for this country to build out the NAIR. So I would like to seek your help in reaching out to your communities at your universities, whether they're in the computer science graduate department, undergraduates in physics or chemistry departments. If your communities and your university colleagues are struggling to find resources, we absolutely need to hear from you. We want to get responses from across all 50 states, diverse institutions, rural institutions. so that we can go to stakeholders and show there is an across the board demand for these resources. All right, and I know we'll at least get 4 digits. In terms of I just want to take a step back in terms of the intended users of the NAIR. It is intended to be for AI researchers, those that are investigating model behavior at a deep level, but also for domain scientists that are applying AI to their particular science area. And the third area where the NAIR is intended to support is students and educators as well. And so we have certainly heard from professors and teachers that they don't give the homework assignments they otherwise would have because they don't have the resources for their students to get on and train a model or do some calculations. And so the NAIR, while it will not support developing AI curricula, it can support infrastructure for those classrooms. The initial focus areas for the NAIR are described here. This first call that is going out in January will focus on responsible AI, trustworthy AI as the key theme. And then in the March timeframe, we will open up the areas more broadly to include healthcare themes, environment, infrastructure, sustainability, themes, as well as AI education. So we intend to organize the pilot, at least initially here, into some different focus areas, some different tent poles. One is NAIR Open, and this will be run very similarly to the, or I'd say inspired by the HPC COVID-19 consortium. And so we'll have access to a diverse set of computing and data resources through this centralized portal and coordinated allocations. Another thrust area here is NAIR Secure. This will be led by DOE as well as NIH, and we'll be investigating privacy preserving enabling AI research that requires a higher level of privacy or security, and assembling really exemplar privacy preserving methods. Another key theme will be NAIR software. I'm getting many emails and calls from, I would say, state consortia that are developing their own AI initiatives, and they want to know how they can plug into the NAIR. And so we want to make, in the future, we should be able to have those campus systems and clusters or statewide regional consortia be able to use a software stack, or at least have a set of common software packages that can be available at the NAIR, on the NAIR systems at a national level, but also at the universities and smaller scales. Clearly, we're not going to get there on day one. I think NAIR software is a way for us to be able to kind of take a step back and look at those requirements. And one of the reasons we pulled NAIR software stack out was that I think DOE, NIH, NSF, we were all really interested in some of these key theme areas and wanted to make sure that that software stack could apply to both NAIR Open and NAIR Secure. And then the final really thrust area here is around NAIR Classroom, which I mentioned. We want to reach really broad communities, the undergraduate community level as well, and be able to provide AI resources, research resources to classrooms as well. Okay, and so wrapping up here, in terms of the NAIR pilot opportunities and how can you help, first of all, again, we really can use your help in getting the word out to your communities. The NAIR is intended to reach researchers from across different government agencies, local governments, state governments, academia. And so you can help us with getting the word out for the call for NAIR pilot allocations, as well as this survey. I will note that the first NAIR pilot opportunity, I call it an aligned opportunity, is out, and that is with the Educate AI DCL. This DCL is not only focused on infrastructure, but it was something that we were working on within NSF, and we are able to include AI infrastructure as part of a focus area of that DCL as well. And then finally, past the launch, we are going to be hosting a series of community meetings, technical workshops, and I hope many from this community will be able to participate as well. So with that, I will wrap up. I'm hoping to engage and talk with many of you today. I do have some of these NAIR pilot launch calls this afternoon, but I hope to come to the reception this evening and talk with you and learn more about your research and how OAC can help. So with that, I believe I left some time for questions, and I'm happy to take any now.